moving into terminal count.
We're getting ready to transition to internal power, both for the spacecraft and the rocket. That's coming up in just 20 seconds. We're watching the boosters as they fill. They are close to getting complete.
NY RP1 load is complete.
Another booster down for RP1. Actually 3 now. So now we move to the filling of the LOX and the completion for all 3 first stage boosters.
Okay, and I'm good to run that now.
Listening in for the switch to internal power. Beautiful shot of the rocket, Falcon Heavy.
Spacecraft is on internal power.
There's the confirmation. The spacecraft is now on internal power. The Psyche spacecraft that you see there encapsulated between those 2 fairing halves.
Vehicle tanks are pressing for Strongback retract.
So there we heard the team is pressing the Strongback to get ready to retract the transporter erector, or Strongback as you refer to it, away from the vehicle just prior to launch. We saw a shot there at the fairing, and that structure will move here in about 10 seconds as they retract that. Things are continuing to move pretty quickly here, Daryl, as the team preps for a T0.
Strongback retract has started.
So now let's take a view up at the top of the rocket where we can see the clamp arms. They will begin to release the rocket. And just about the midsection of the rocket, midway up. We're also waiting for the NLM pole, which is coming up in just a few seconds. A final check with the NASA launch manager, Tim Dunn, by launch director Mike Taylor of SpaceX.
LD, NLM, countdown net.
LD.
The NASA Psyche team is go for launch.
Copy, go for launch.
Great news there. The spacecraft team is ready. NASA's launch team is ready.
LOX load is complete.
Yep, and there we heard a call out for a LOX load on one of the side boosters is complete as the team continues to fill the tanks and top them off. Getting ready for launch. We should be hearing the other 2 side boosters finishing up along with stage 2
LOX load
complete. There we heard the other side booster is complete with LOX load, Daryl.
These 2 side boosters, they'll be coming back today, so if you're here locally, you're going to get quite a show. Boosters 1064 and 1065, which have flown 3 previous missions, 2 DoD.
Center core LOX load is complete.
And 1 commercial mission. They'll be coming back about 7.5 minutes after liftoff, so look to the sky for that, especially that entry burn and landing burn. They'll make a sonic boom that you can't miss.
Yeah, absolutely. We are looking forward to those 2 boosters coming back. And as we talked earlier, that center core will be expendable. We will use all the propellants for Psyche today. And if you look at the launch vehicle, one of the unique things about that center core being brand new and expendable is you'll notice there's no grid fins or landing legs on that. And that is done by purpose to make sure we get the complete performance out of that center core for that trajectory that Jarmaine talked about to allow Psyche to perform its mission.
Always good to save some mass when you're flying a rocket to space. And those 2 side boosters, NASA has eyes for them for the Europa Clipper mission.
We do. Actually, the side boosters will be used on a...
Stage 2 LOX load is complete.
Stage 2 LOX load complete call out there. But those side boosters will be used on a Space Force mission later this year and or maybe early next year, and then we are looking to use those as our prime side boosters for the Europa Clipper mission in 2024.
And with that call out that stage 2 LOX is complete, the Falcon Heavy is now completely tanked with 2.8 million pounds of propellants. Getting into the final minutes of the countdown now. T-minus 1 minute and 37 seconds.
Gas launch closeouts.
So you heard there the ground gas closeouts, and see that burst of LOX coming off the side of the rocket there? That is emptying out the LOX line in the transporter erector, or Strongback. Getting down to the final minute now.
Falcon Heavy is in startup.
Good call out that the Falcon Heavy is in startup. Now we're going to get the go at T-minus 45 seconds.
Go for launch.
We are go for launch. All systems are go to send the Psyche spacecraft to deep space.
30 seconds. $15 seconds.
And here we go with the final seconds of launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of Falcon Heavy and Psyche on a mission to a metal asteroid in deep space to study the building blocks of our planet's inner space.
Vehicles pitching downrange.
M1D chamber pressure is nominal.
View there from the onboard camera on the booster. Beautiful shot there as it goes through the clouds.
Power and telemetry nominal.
Over here, Dale, the power telemetry are nominal. We're also looking at the data for all 27 engines. And
Falcon is supersonic.
All chamber pressures look good, and Falcon is supersonic now.
Throttling down in preparation for max Q. A moment of peak mechanical stress on the rocket.
What will happen here
Max
is
Q.
the side boosters will be at full power, and the center core will be at a reduced power to go through max Q to reduce the pressures on the structure of the launch vehicle.
Coming up in 30 seconds. We'll start getting ready to have those boosters cut off.
Vehicle's looking good, pitching down range. All telemetry looks really good so far, Daryl. As we see a beautiful view of the Falcon Heavy and center core and side boosters there. Data is looking really good.
All 27 engines of the Falcon Heavy putting down 5.1 million pounds of thrust. Standing by now for booster engine cutoff for those side boosters. The center core booster will continue on.
Booster engine cutoff.
Side booster separation confirmed.
Great shot there of the side boosters coming off the rocket.
MVAC engine chill has started.
And there we start the chill on stage 2 as we get ready for MECO on the center core. Stage 2 will continue chilling down, making sure the fuel and propellants are flowing through that MVAC, getting ready for ignition.
Those boosters will have 3 burns, 2 re-entry burns and 1 final landing burn before it comes back down at LZ1 and LZ2, landing zone 1 and 2 here at the Cape. Next up is main engine cutoff of that center booster. After that cuts off, there'll be a series of steps that will happen in close succession. Main engine cutoff. The center core stage will separate, and then we'll start the second stage burn, the first of 2 burns today.
There we see a shot inside
Back
the.
shutdown.
That was a shutdown.
Looking
Main
now
engine cut
inside
off.
the booster. There you have Miko,
Stage separation confirmed.
and there it goes. You're looking at the second stage in front of you, lighting up its
MVAC
MVAC
ignition.
engine. Split screen now on your right-hand side.
Center core FTS is saved. Bermuda.
Calling out the communication stations. What a beautiful shot there, while we had it, of stage 2.
Daryl, we continue to look at the side
Bearing
boosters.
separation confirmed.
Boostback has been completed, and they're in extended coast right now.
And there go the fairings. Revealing Psyche to the atmosphere. You can see the fairing falling away back to Earth. SpaceX has their recovery vessel.
Vehicle is on a nominal trajectory.
Their recovery vessel, Bob, is out in the waters right now, looking to recover both of them. Getting a good burn now from the second stage. This lasts about 4 minutes. We are going out over the Atlantic Ocean, heading south towards southern Africa. On the right-hand side, you see the glowing engine of the Stage 2. We've got 2 cameras there. On the left, we're tracking those boosters coming back down.
Yeah, we should see in about 20 seconds, we should see the booster entry burn, which is be the one engine on both side boosters.
Quite a clear image in space on the right-hand side. We've got clouds overhead on the left, but you can see at the center, we're tracking one of those boosters, also tracking the second stage, it looks like right there.
Yeah, all the data so far, telemetry is looking nominal. I see the telemetry chilling down the engines for that booster entry burn on the side boosters, starting up in the telemetry. Everything's looking nominal. The vehicle second stage is performing very well, and side boosters are coming back.
Boosters entry burn startup.
And there we just heard booster entry burn startup is happening. And seeing the entry burn getting ready to go on the side boosters.
Boosters entry burn shutdown.
And there we saw the booster entry burn on one and shutdown. And there we see booster entry burn on the second side booster and shutdown.
Next burn is the final landing burn. And for
TYNY FTS is saved.
And for folks who are in the area, you end up hearing that loud sonic boom, that thunderclap, just about the time they make landing.
Stage 2 is on a nominal trajectory.
You and I here at Hangar AE, just a couple of miles away from this landing zone, we certainly hear it and feel it.
Yep, and I see now that the side boosters are supersonic, transitioning to transonic.
And that's a shot of the booster through a thin layer of clouds.
We heard the call out for transonic. Landing burn has
Stage 2
started.
and terminal guidance.
Here it comes.
I don't know, Daryl, but that sonic boom was great for us. I'm sure Jim is excited over there. There's the second one. I'm sure the host desk over there is feeling that really well.
Literally, our monitors were shaking as both those boosters broke the sound barrier.
And we just heard booster landing confirmed, as we see on the screen, both
back
landing
shutdown.
zone 1 and 2. Everything looks great. And then the call out for
Stage 2 FTS is safe.
Psyche 1, Stage 2 engine cutoff. So, Daryl, this will put us into that 45-minute coast that you and Jarmaine were talking about, allowing us to do
Nominal
that
park
barbecue
orbit
roll.
insertion.
Absolutely. We're looking forward to that. And as you look at your screen there are the two side boosters on their landing pads, coming down more staggered than I'd seen them before, but nonetheless, perfect landings for them both. And now we will continue to track this right here, the second stage of the Falcon Heavy, along with the Psyche spacecraft right there looking forward. You can see the spacecraft on the right-hand side. It will be coasting now for about 45 minutes. And when we come back, we will bring you the moment of separation. In the meantime, we'll send it back to Megan and Jim at the host desk.
And if you're just joining us, welcome live to Kennedy Space Center in Florida, where we just saw a Falcon Heavy rocket launch off with Psyche, the spacecraft. Jim, speechless. Speechless. Actually, you weren't speechless during the launch because you were standing next to me, and he just kept on saying, "Go, baby, go!"
Oh, it was so powerful, so incredible. Just, the light, the sound, you felt it in your bones, just shaking us as this thing goes up.
I saw the range of emotions. Like, you were super excited, and then you got quiet. You got really quiet.
Well, there's a lot riding on this for the whole team, right? For all the hundreds and thousands of people that have been involved with this. And it's just, what a great ride so far.
Yeah. How did you feel also hearing and feeling those sonic booms? I was kind of worried because we saw it in the video, and we were like, are we going to feel it here? And all of a sudden, boom, boom,
Yeah.
boom.
That was very exciting, very exciting. So, and it's just great job landing those boosters, because we want to reuse them for Clipper next year.
Yeah. Anything you want to say to the team? Again, as we just saw at Liftoff, you said all that hard work, all that time.
Yeah. No, this is just, it is a team effort, and, we're going to be collecting this data set and studying this planetary core for future generations. Really, it's going to be spectacular. Data, images, chemical data, magnet field data, gravity data, and really, we can't study the Earth's core any other way. So here's maybe how cores grow and what's happening inside our own planet.
Yeah. So the Psyche mission is going to explore the metal-rich asteroid, also named Psyche. And why don't we take a closer look at Psyche now? It was first discovered in 1852. We don't know exactly what the asteroid looks like, but scientists have combined radar and optical observations to generate this 3D model you're looking at right now. Shaped like a potato, at its widest length, it's 173 miles. That's about the same as driving from Houston to Austin, Texas. There's evidence of two crater-like depressions. It appears to have a significant amount of metal, and a day on Psyche lasts only about 4 Earth hours. So as Psyche's imaging lead, tell me, when can we expect the first photos?
We have to spend, once we complete the deployment, we have to spend many months just checking out the systems, propulsion system, communication system, computer system, everything, right? Communications. And part of that is checking out the instruments. So I think the magnetometer might get checked out first, because they're trying to detect some of Earth's magnetic field before we get too far away. And then in the weeks after that, we'll be testing out the imagers, taking pictures of stars, calibrating the cameras, getting the geometric correction just right, and getting ready for our eventual flyby of Mars, where we'll get lots of more great pictures as we pass by Mars. And then, of course, we'll start seeing Psyche as we get close to the end of this decade in late 28, early 29. It'll go from that point of light that we can see in telescopes to its own little world.
Yeah, the fact that right now it's so far away, again, orbiting the Earth between Mars and Jupiter, 3 times farther from the sun than Earth is, to be able to study it now up close, that's amazing.
It's very exciting, right? Yeah.
And the fact that we're going so far out to learn more about our home planet, I think that's so fascinating.
It is, and I love the fact that, this is something we're going to share with the whole world, right? It's a point of light in the sky right now, but we're going to see it become a world as it gets bigger and bigger in the windshield as we get closer.
Perfect. Now, NASA's Jet Propulsion Laboratory in California is managing this mission. I also hear you're managing a very excited crowd right there.
Thanks, Megan. Yes, back here at JPL, there was so much excitement, clapping, cheering, high fives, and just take a live look from inside Von Karman Auditorium. We invited friends and family to come here today and watch the launch together. They're taking some photos right now, and when the launch happened, the whole room started clapping and cheering, and they are wearing their Psyche gear there. So Psyche may be off the ground, but its twin is still here on Earth. It will support testing on the spacecraft journey to a metal-rich asteroid. Psyche testbed engineer Joan Tubangbanwa joins us now to tell us about it. Thanks for joining us, Joan.
Thanks, Raquel.
So how would you describe Psyche's testing twin?
Yeah, that's a great question. Psyche's testing twin is called the testbed, and it is located at our spacecraft assembly facility here at JPL, which is the same place where we built the Psyche spacecraft. Now, the testbed isn't something that you can just get from the mattress store, nor does it look like the spacecraft or a mattress. In fact, it's hardware that stays here, and if you look at the picture, it's connected by these snake-like wires that is designed to have the same software that the spacecraft is running with, which is also called its brain.
Now, Joan, you are about to start your shift here in the mission support area. What will you be working on?
Yeah, it's a super exciting time right now. The testbed is closely following behind the Psyche spacecraft as it progresses through the launch procedure. My shift begins when we first communicate to the spacecraft since liftoff, and this is done through something called commands. Now, commands are directions that we give to the spacecraft, which we tell it what to do and what kind of information that we need from it. The room will be making sure that the spacecraft is in a safe state, while the testbeds are sending the same commands and simulating the same data that we would get from the spacecraft. If anyone in the team or in the room was curious about a specific command, we would first test it on the testbed to see that we get the expected response.
Lots of work ahead. Now, Joan, you're not saying goodbye just yet. Tell us what's next.
Yeah, so of course I'll be celebrating a successful launch with my family, who's actually in Von Karman Auditorium right now, came all the way from New Jersey. October is also a special month because it is Filipino American History Month, and I was born in the Philippines, and so we'll be putting on an event that highlights both Psyche and our Filipino American team members. And lastly, I'll be following Psyche's journey, making sure that our testbeds are operating alongside the spacecraft.
Joan, thank you so much. I'm glad you were able to celebrate with your family. Megan, back to you.
Filipino Joan. And we were happy to host JPL's director here at Kennedy for launch. She's with NASA's Jasmine Hopkins, and they had a great view of liftoff.
Thank you, Megan. That is right. The crowd was so excited here on the balcony to see that beautiful liftoff of the Psyche launch. We're honored to be joined by Lori Leshin, director of JPL. So, Lori, this is a coast-to-coast mission from JPL to Kennedy. How do you feel to be here for launch?
So thrilling, so exciting to see that rocket light. There's nothing like it, and you see it, and then you feel it, and then the emotions really start.
Exactly. That was the perfect description of what we just saw. And there are a lot of emotions attached to this for you. The team at JPL has been working on this for years. So what do you want to say to the team at JPL and your partners about today's launch?
I am so incredibly proud of our team at JPL. I'm waving to all of you right now. I will say I was out at the launch pad a few days ago in the hangar with the rocket. It was laying down, and I just took a few minutes away from the group to stand underneath the fairing and think about all the thousands of hands and minds and hearts that have gone into making Psyche possible at JPL, at all our partners, and I just couldn't be more thrilled to represent them.
Exactly, and it's really like a relay race. You know, today's the beginning with launch, but you guys have 6 years before you get to Psyche, so
yes.
What is next? What's the work being done at JPL?
So right now, it's all about picking up from the launch team and getting our spacecraft separated from the rocket, power positive, checking out all the systems, and starting thrusting in just a few months to get us on out to Psyche, 2.2 billion kilometers away.
Yeah, exactly. A lot to look forward to. Thank you so much, Lori Leshin.
Thank you.
Of
go
course.
Psyche.
Yeah, go Psyche. Megan and Jim, back to you.
The Psyche mission is a collaboration between NASA's JPL, as we just saw, Arizona State University, and NASA's Launch Services Program in Florida. Let's meet some of the other people who made this mission possible.
At the end of the day, it's always a philosophical question, right? Of why are we in this universe?
Space just inspires everyone of different backgrounds, different nationalities. So I think it gives, in a sense, kind of hope for humanity.
As human beings, if we're not exploring, then what are we doing?
It's extremely difficult science and technology, but it's possible.
My name is Luis Dominguez, and my job is to assemble all the different components for the Psyche spacecraft.
I'm Julie Lee, and my job is to propel the Psyche spacecraft to a metal-rich asteroid.
Hi, I'm Benny Noy.
My name is Christina Hernandez.
My name is Veena Srikantamurthy.
And I'm making sure that we built a spacecraft that's ready to explore a metal world. What's really exciting about Psyche being a metal-rich asteroid is we haven't yet had the opportunity to explore a planetary core. And that's what we actually think happened to Psyche.
There is a theory that this metallic asteroid may be very closely related to the materials that made up the core of our own planet.
It could have been the remnant of a planetary collision billions of years ago in our solar system. All that's left is the metal-rich remnant.
Scientists hypothesize that by studying this asteroid,
we think that could give us a lot more insights on what our actual planet is doing.
So this is the Psyche spacecraft. We're basically looking at a spaceship that's going into space.
And welcome to High Bay 2 at JPL. We pulled together all the different components that everyone's building, and so this is where we control the Psyche spacecraft. They dictate how things happen on the floor.
This is where I worked on the low voltage power supply for the Psyche mission. It's pretty exciting to watch something that we built with our own hands.
To see something that you've spent years on.
Launch, and in a couple of years reach Psyche and send back science data.
We formed a really, really critical team.
The diversity of skill sets that each one of us in our community brought to the team to make this kind of impact to society is what inspires me to be an engineer in the space exploration sector.
Now, Jim, we just heard from some of your colleagues. Tell me, what does it feel like for you to be part of this team?
Oh my God, it's such an amazing team, Megan. And you saw some examples there. It's scientists working with engineers, all kinds of engineers, all over mechanical, software, communications, propulsion, power, every kind of engineering you can imagine. But it's also, we're working with managers, administrators, communications experts, educators. I mean, it's just such an amazing collection of people, a community of people that it takes to make this kind of thing happen. And I know they're all just super excited right now.
Yeah, and somebody said, what inspires them? What inspired you to be a part of Psyche and to want to go into this field?
When I was a kid, there were astronauts driving cars on the moon on TV. And it's like, I want to do that, and I've always just been hooked on it. Had a telescope when I was a kid, got to know the night sky, and just been really fortunate to be able to pursue all this as a career.
Yeah, I can still feel how emotional this is for you. Are you okay? We're back to excited. We're back to excited. All right, it's now been about 20 minutes since launch. Let's go back to JPL and Raquel again for another update on the Psyche spacecraft. And Raquel, the mission support area is working in shifts, yeah?
That's right, Megan. A team switched the spacecraft to internal power, and now that the spacecraft has launched, they'll pass the baton to a new team who will work to make the spacecraft fully operational. Joining us now is Psyche systems engineer Christina Hogstrom, who tested the spacecraft and can tell us what comes next. Good morning, Christina.
Good morning, Raquel.
So tell us what you'll be working on when you take over this workspace.
So right now we're waiting for the launch vehicle to get into position to let go of Psyche. And after that point, we'll be monitoring closely and waiting for that first signal from the spacecraft. Once it separates from the launch vehicle, Psyche is going to autonomously turn on its radios, deploy its solar rays, and then put itself into a slow spin at 1 revolution per hour. And that's to keep the temperatures uniform, which is why we call it rotisserie mode. Once it's in that spin, the antenna that's beaming the signal to Earth is going to be rotating in and out of our view. And so it could be anywhere from a couple minutes to a couple hours before we hear from the spacecraft. But as soon as we do, we'll look at the data, we'll make sure that it's still healthy, and then we'll start talking back to it. We'll command it to stop that spin, keep the antenna pointed at us, and then we will work to get it into its fully operational mode.
And we heard from Joan that there is a testing twin on Earth, but you actually tested the spacecraft itself. What kind of tests did you do?
Oh yeah, we really put the spacecraft through the ringer. I helped to coordinate this test where we put the entire thing in a giant vacuum chamber. We sucked all the air out to simulate deep space. And then for 17 days continuously, we made it super hot, we made it super cold, we made it hot again to make sure that the spacecraft could operate in those extremes of deep space. And then there was another test where we put it on a big table and we shook it to simulate the launch vibrations that it's seeing today. as much as we can over and over. We've checked every wire, we've tested every function on the real spacecraft as long as it's safe for the hardware. Anytime we have a brand new version of the software that's on board the spacecraft controlling it, we always test that in the testing twin first to make sure it works, and then we still prove it out on the real spacecraft. And the whole process is iterative. So we start on the testing twin, we test something, we learn something, we fix it, we test again, and then we move it to the real spacecraft, we learn something, we fix it, and we start the process over. And that's why it takes us years to be absolutely sure that we're ready for today.
Sounds like it is ready for its journey. Now, you've been with the mission for 4 years. What is happening next for you?
Oh my goodness, it is surreal. This is my first flight project, and I've just learned so much. I've had the opportunity to have a lot of different kinds of jobs on Psyche, from temperature regulation to fault protection, that's like autonomously detecting and correcting for problems. I even helped out with electric propulsion early on, and nowadays I'm on the operations team as kind of a systems generalist. I've seen this thing grow up from designs on paper to a robot that's on its way to space today, and I just am so super excited to continue on and fly this thing that we've worked so hard to build. The next 100 days are going to be pretty crazy for the operators. We're going to be checking things out, turning things on for the first time, making sure that everything's going swimmingly, and then we'll have a much more relaxing cruise to the asteroid, and I just can't wait to see what we find when we get there. I'll be on this journey to a metal world every step of the way.
Thank you, Christina. Back to you, Megan.
Now, we asked for questions, and you sent them in. Jim,
yes.
Are you ready to answer?
I am ready. Bring them on.
I wasn't ready to say that, but now I'm ready. Okay, so let's play the first question.
I am Paola, and I'm from Serrano Elementary School in Moreno Valley, California. And my question is, how much time is Psyche gonna spend studying Psyche 16?
It's a great question that Paola asks. And so first of all, it's going to take us almost 6 years to get there.
That's right.
So we have to fly by Mars and slowly coast out, power ourselves out with those electric thrusters. And then when we get to Psyche, we'll start up high in this 33-hour orbit, and we'll spend a little more than 2 years, 26 months, slowly getting closer to the surface and getting higher and higher resolution and map this whole thing and get its chemistry and magnetic field and all that kind of stuff. So about 26 months.
Awesome. Great question, Paola. All right, let's take the second question now. How can an asteroid have enough mass and density to support a molten metallic core?
That is an outstanding question. And the answer, we think, is that this asteroid was part of something much bigger, right? And so it had more gravity. And with that gravity comes internal heat, pressure, internal heat, and it's got radioactive elements inside of it as it was forming. And so it's really hot on the inside, and it can get molten. And we think that the part we're seeing now is just what's left over after maybe a big impact, a grazing impact, knocked off the mantle and crust. We're going to test that hypothesis with the Psyche mission.
Okay, let's squeeze in one more question. This is Andy Zhang on H. How long did it take to research and develop this mission and the Psyche spacecraft?
Well, it's the better part of 10 years.
Yeah,
We saw earlier in the show that, it all started with some scribbles on a whiteboard and, folks thinking ideas about how can we learn about planetary cores, how can we figure out how planets form. We can't study the Earth's core. Hey, let's go visit a metallic asteroid that might be the remnants of a core. And so that idea from sort of 10-ish years ago became a proposal, a pitch to NASA in a competition that we won. To mount a Discovery-class mission. And the spacecraft started getting built. We got selected in 2017, and then probably about 2018 or 19, we started building and testing the spacecraft. And here we are in 23, and it's off the ground.
And you know what? I just realized I never said congratulations to you.
Thank you. The whole team. It's really, like I said, everybody's just ecstatic right now.
Yeah. Okay, great questions, guys. Keep them coming using hashtag AskNASA. But right now, I need you all to take out your phones or get ready to take a screen grab if you're watching us on your phone. We're going to pull up another QR code for you, and this one will take you to NASA's Eyes on the Solar System page. This is really cool. You can track the Psyche asteroid's current location along with other asteroids and comets in our solar system. And once the Psyche spacecraft is communicating back with us on Earth, then you can also track its location too. Now, the Psyche spacecraft will gather new data that will be studied by researchers around the world, including the curator in charge of the U.S. National Meteorite Collection at the Smithsonian Museum of Natural History. Take a look.
When I was a little kid, I thought I wanted to be an astronomer. And I took a geology class, and there was just something about having a rock in your hand, something you could hold and feel. I thought, you know, we have rocks from outer space. Maybe I'll study those. I study meteorites. I love meteorites. It's like an addiction for me because I love exploring the solar system through understanding these rocks and the places they come from. Life on Earth exists on two heat engines. One is the sun, but the other is the heat engine below our feet that drives the movement of the plates. It drove the differentiation of the planet. We've known for 2 centuries that our core was made of metal, but we haven't been able to explore it. We can't drill a hole that deep. We can't explore with any kind of submersible in the oceans. What we've been looking for years is a metallic asteroid, something that's very dense. Psyche is an asteroid 200 kilometers across, thought to be metal rich. Psyche is our way to explore our own planet. We have meteorites fall to Earth. Some of them are little tiny pieces. Some of them are the size of cars. But compared to Psyche, they're just tiny little specks of dust. When I first started as a graduate student, we had never visited an asteroid. Not any of them. Asteroids were points of light in the sky, and now they're real geologic places. They're places we can visit. More than the awe, more than the wonder, so we have this responsibility to do this right. And that's why this part is so important. What we're doing right now, designing these
acquisition of
because
signal,
that will determine whether we get the data that graduate students 10 years, 20 years, 30 years from now will learn things about this asteroid that we can't even imagine today. It's the journey of a lifetime, and I didn't want to miss it.
Now, NASA has dubbed this fall Asteroid Autumn for all the fascinating things we have going on with asteroids around our solar system. For more on that, let's bring back NASA's Jasmine Hopkins.
Thank you, Megan. Yes, 'tis the season of asteroids. Here to talk to us more about Asteroid Autumn are Nikki Fox and Lori Glaze. Thank you for being here. We are so excited. So we are in Asteroid Autumn, but no 2 missions are the same. Nikki, tell us what makes Psyche unique.
Well, first of all, Psyche just launched. So, I mean, it's right, awesome. So, but Psyche is going to a metal-rich asteroid, and there are only 9 that we know of in our solar system, but Psyche is huge compared to the other ones. It's the size of Massachusetts. So we're going to go and actually visit a metal world for the very first time. We don't know what we're going to find, and that's what's so exciting about NASA science. Every time we launch a mission, we do unique, cutting-edge science, and this one is going to be absolutely no different. We cannot wait to get that out there, that spacecraft out there with Psyche.
Exactly. That was the perfect way to characterize it. We keep doing unique first. So actually, Lori, you were just in Houston as well as the administrator for the unveiling of the OSIRIS-REx sample return. So what are we finding with that mission? What is next?
That is an amazing mission, and as you said, I was just in Houston 2 days ago on Wednesday. It was absolutely spectacular to be there and share with the entire world kind of our first look at what that sample is. But really, it's the very beginning of the analysis process. We've got so much incredible science to do, but what was so unique about that particular sample was we're finding water in the sample. We're finding carbon, an incredible amount of carbon, more than we've ever seen even in the meteorites that we have here on Earth. So there's just so much new discovery to come. Keep tuned on OSIRIS-REx over the next several months, and I'm sure there'll be a lot more great new data.
Exactly, and we're actually not at the end of Asteroid Autumn yet. The Lucy mission is about to have a close flyby, its first asteroid encounter since launching in 2021. What are we looking to find from that?
So again, we're going to be going to an asteroid. It's a little one, so it's very, very different from Bennu, and it's different from Psyche, and we're just going to learn a lot because it's going to be the very first time that we've actually visited this new world. It also gives us an opportunity to actually check out the instruments and make sure everything's ready for when Lucy actually gets into the Trojan belt and starts the flybys in there. And I have to just give a shout out to DART. It's also part of Asteroid Autumn, and we just celebrated that 1 1-year anniversary of smacking that on the nose. But Laurie is going to tell you why Lucy is so important.
Yeah, so the Lucy mission, as Nikki said, of course, is going to fly by a little asteroid named Dinkinesh, and it's a main belt asteroid. But the real goal of Lucy is, at the end of this decade, is to explore several what we call Trojan asteroids. And they're Trojan because they kind of hide, right? You find the Trojan asteroids leading and trailing Jupiter in its orbit around the sun. Interesting fun fact, those asteroids, even though they're in Jupiter, the orbit that Jupiter's in around the sun is actually closer to Earth than Jupiter. But those asteroids are incredibly important for telling us about the early part of the solar system, where the giant planets were and if they migrated or moved over time. Those asteroids were picked up and held in that gravity field over time. And so the different asteroids we're going to visit will tell us about that history.
Exactly. A lot of great things going on with asteroids right now. Nikki, Lori, thank you so much for being here.
Go Psyche.
Go Psyche.
Of course, go Psyche. Jim and Megan, back to you.
I love to see how excited they are. I also love that we do have this big screen there that's showing you the trajectory again of that second stage with Psyche. Now, we are 33 minutes since launch. Once this Psyche spacecraft is on its own, the spacecraft will use solar electric propulsion to move through space. Now, that's a super efficient system being used for the first time beyond the moon. First, Psyche's solar arrays will convert sunlight into electricity. That electricity will power the spacecraft's 4 Hall thrusters. Those thrusters will use electromagnetic fields to turn Psyche's propellant xenon into thrust, and that thrust will gently propel it through deep space while emitting that cool blue glow you just saw there on your screen. Now, Jim, when we're talking about gently, it is very gentle. Can you tell us about that?
It is very gentle. How gentle is it? It's so gentle. Hold out your hand.
Okay.
I have 3 quarters here.
All right.
It has about the same amount of force as those quarters.
Feels like nothing.
Nothing.
Absolutely
it's like
nothing.
a bag of feathers,
Yeah.
right? I mean, it's very, very gentle. So tiny but mighty, right? Because you exert that force over time, just continuously. So instead of just like one big main engine burn, it's just a slow, gentle process with that beautiful blue glow.
Yeah.
And that accelerates us out to like 125,000 miles an hour on our journey out into the solar system.
And that's essentially because even though it's nothing, if there's no atmospheric drag to push it back, it just keeps accelerating.
Exactly.
Interesting. Wow. Now, Maxar Technologies supplied Psyche's 4 Hall thrusters. You can see them there. Engineers estimate that if this mission used traditional chemical thrusters, it would have burned through about 15 times as much propellant. Now, Psyche is carrying 3 science experiments on board. Check out how they'll discover the asteroid's composition without even landing on it.
Psyche is a unique object in the solar system.
To us, Psyche is this really unusual body giving off really unusual gamma ray neutron signatures.
Technically,